This is part 2 of week 2. We're going to cover dose based on stock, percent concentration, and dilutions. So in order to calculate dose based on stock, you need to ask, what is the strength of the medication that you have available? Is that what the doctor ordered? And how much will the patient need to take at each dose? The doctor ordered the patient to take 2.5 milligrams of Coumadin daily. In stock, you only have 5 milligram tablets. How many tablets should you dispense for a 30-day supply? What should a label for the patient read? So you can solve this problem by using a proportion. And on one side of the proportion, you have your unknown, or in other words, your question. And on the right side, or whichever side you choose to put it on, you have your known relationship. Okay, so we know that we have one tablet, and one tablet is equivalent to 5 milligrams. On the left, we have 2.5 milligram, and we don't know how many tablets we need to make 2.5 milligrams. So after our proportion is set up, we're going to cross multiply and divide. So n tablets times 5 equals 5n. 2.5 milligrams times 1 tablet gives you 2.5. And then you divide both sides by whatever number is with the letter. And we see that 5 is with the letter, so we divide both sides by 5. And 2.5 divided by 5 is equal to 0.5, and you get 0.5 tablets. Or you can solve this using a formula. I like to use this formula. This is one that I can use in my head pretty often. So it's order over stock times the dosage unit equals the dose. So the order is what the doctor ordered, which is the 2.5 milligrams, and divided by 5 milligrams, that's what we have in stock, right? And times the 1 tablet equals 0.5 tablets. Identifying important information. So one of the most important parts of answering dosage calculations questions is reading the problem and identifying what the question is asking and what the information in the problem represents. So we have a prescription that says QPAP 160 milligrams over 5 ml, dispense 180 mLs. And the instructions say take 2 teaspoons by mouth twice daily. How many milliliters is there per dose that we have? So we look and we say for each dose they're taking 2 teaspoons. 1 teaspoon is equivalent to 5 ml. That means that 2 teaspoons is 5 times 2 equals 10 ml, right? So per dose, they're taking 10 ml. And dose means how much the patient is required to take at one time. So the patient is required to take 10 mLs at one time. Whereas twice daily, the patient is required to take it twice daily, however, and that means that's the total daily dose. Okay? So how many milligrams is a patient taking per dose? So how do we calculate this? We're going to do 160 milligrams over 5 ml. And you can multiply that by 2, right? Because they're taking it twice. So you multiply both the top and the bottom by 2. 160 milligrams times 2 is 320. And 5 ml times 2 gives you 10 ml. So what does that mean? That means that the patient, for every 10 mLs, they're getting 320 milligrams of medication. So this answer is 320 milligrams. How many milliliters per day? The patient is taking 2 teaspoons by mouth twice daily. So they're taking the 10 mLs, right? That means that they're taking the 10 mLs twice a day. then they're taking 20 mLs per day total. So at one time they're taking 10 ml, and then a second time throughout the day they're taking another 10 mLs. That equals 20 mLs. What is the day's supply? So to calculate the day's supply, we need to look at our dispense, which is 180 ml. And then you divide that by the total daily dose, which is 20 ml. And so 180 divided by 20 ml gives you 9, right? So it is a 9-day supply. All right. And what we did here is we did the dispense divided by the total daily dose, and that gave us the day's supply. So now we're going to calculate strengths based on percents. So the strength of many solutions can be expressed as a percent. Solutions contain two parts. One part of a solution is a solvent, which is a substance in which the drug is dissolved. Two, the other part is a solute, which is a medication or the stuff that is being dissolved. If the solute is a solid and the solvent is a liquid, the units are grams per 100 ml, and that's a weight by volume. If the solute is a solid and the solvent is also a solid, the units are grams per 100 grams, and that's a weight by weight. If the solute is a liquid and the solvent is a liquid, the units are ml per 100 ml, volume by volume. So, for instance, if you see this on the left, the bag of sodium chloride injection fluid, it says 0.9%. So 0.9% means 0.9 grams of sodium chloride in 100 mLs of solution. And sodium chloride is a solute, and the 100 mLs of solution is a solvent. So finding information using proportions. Let's try a few examples to solve this percent concentration problems. Okay, so how many grams of zinc oxide are contained in 60 grams of zinc oxide 40% paste? So we can set up a proportion to solve this. See, on our left hand side we have our known relationship, and our right we put our unknown. So we know that based on the 40% paste, right, that it's 40 grams of zinc oxide over 100 grams of paste. And then our unknown, we want to figure out how many grams of zinc oxide are contained in 60 grams of zinc oxide. So we have the 60 grams of paste, and N is because we don't know how many grams of zinc oxide. So we cross multiply. 40 grams times 60 equals 2400. N times 100 equals 100N. And we divide by whatever numbers with the letters. So we divide both sides by 100. And that gives us 24 grams of zinc oxide. Let's try another one. How many grams of miconazole powder are in 45 grams of miconazole 1% cream? So what type of problem is this? This is a weight by weight, right? We have our solvent is a weight, it's given in grams, and our solute is given in grams as well. So 1 gram of miconazole powder over 100 grams of cream, right? We obtained that from looking at that 1% cream in the problem. And our unknown is on the right, so we have N over 45 grams of cream. We cross multiply. 1 gram times 45 gives you 45. 100 grams times N gives you 100N. And you divide both sides by whatever numbers with the letter, which is 100. 45 divided by 100 gives you 0.45 grams of miconazole powder. And if you are having difficulty with setting up the proportion, you really should go back and look at the video on proportions, setting up proportions and figuring out how to solve them. So this is another problem in which we're doing percent concentration. If you add 6 grams of salicylic acid to 56 grams of an ointment base, what is the final concentration weight by weight of the product? So keywords we want to look for here in problems are add. So we're adding 6 grams of salicylic acid to 56 grams of an ointment base. So to solve this problem, we're going to do the total over the active over total times 100%. And that'll give you the final concentration. So our active here is 6 grams of salicylic acid. So 6 grams. And then we have over the total, which is 6 plus 56, gives you what? $62. So 6 over 62. Let's calculate that. Gives you 0.4838, and then we're going to multiply this by 100%. And that's how you get the percent, 48.38%. So that's the final concentration, okay, weight by weight of the product. Here's another example. How much clotrimazole is contained in 15 ml of clotrimazole, 1% weight by volume topical solution? So this is it tells you it's a weight by volume, okay? So you have the 1 gram clotrimazole over 100 ml of topical solution. Obtain that from your 1%. All right, and then on your right, you have your unknown. So we want to figure out how many grams of the clotrimazole is in 15 ml of solution. We cross multiply. 1 gram times 15 gives you 15. N times 100 gives you 100 N. And we divide by both sides by whatever number is with the letter, and it's 100. So 15 divided by 100 gives you 0.15 grams of clotrimazole. Okay, and here's another example. 4 ounces of active ingredient is added to 500 ml of an alcohol-based solution. What is the final concentration volume by volume? So we're going to use our active over total times 100% to solve this. So you have 4 ounces of active ingredient, right? Wait. Here, we can't just jump into the problem without converting the ounces to milliliters, right? Because we have 2 different sets of units here to measure out volume. We need to make sure that they're both the same. So we want to convert the 4 ounces, right, to milliliters. So we know that 1 ounce is equivalent to 30 mLs. 4 times 30 gives you 120 mLs. All right, we know this because this is known from our table of measurements, right? So our active is 120 mLs over the total, which is 500 mLs, times 100, and that gives you what? So do 120 divided by 500 gives you 0.24, and then you multiply that by 100. That gives you 24%. That's the final concentration.